Okay, today we're going to be talking about section 8-1. We're covering monomials and factoring. Okay, there are a few vocabulary words we need to review before we get moving. We have first prime number. Okay, a prime number by definition is a whole number greater than 1 whose only factors are 1 in itself. Okay, so just quickly listing off, 2 is a prime number, 3 is a prime number, 5 is a prime number, because those numbers only have factors of 1 in itself. Okay, this is as opposed to composite numbers. Okay, so composite numbers are whole numbers, also greater than 1. The main difference being that they have more than 2 factors. For instance, if you're thinking about the number 12, 12 has a factor of 1 times 12, has 3 times 4, has 2 times 6. They have multiple factors, greater than 2 factors. Okay? So what I'd like for you to do right now is to set up on your notebook a list of numbers. Okay? Make sure you have room to write numbers 1 through 10 across one entire line. Please spread out your numbers. Okay? Right underneath, what I want you to do is to fill in 11 through 20, 21 through 30, and you're going to do this all the way through 100. Okay, so what we're going to do is we're going to do a quick investigation to list out all of the prime numbers that are in 1 through 100. Okay, please pause the video while you set this up. Okay, do you have it ready yet? Here's what we're going to do. Okay, this little activity is called the Sieve of Eratosthenes. Okay, and you can actually Google it, and it's actually there's a really cool application on Wikipedia that you can take a look at. But what we're going to do is we're going to start listing out all the prime numbers. We're going to start, prime numbers are greater than 1. So we're going to start with the number 2. Go ahead and box the number 2. And now what you want to do is you want to go through and you want to cross out all of the multiples of 2. We can cross out 4, 6, 8, and 10. We can cross out 12, 14, 16, 18, 20. Are you starting to see a pattern? They're all even numbers and they actually all fall along the same column. Okay, so this looks like a lot of work, but as you start finding patterns, it becomes very, very quick. Okay, so what we're doing is we're crossing out all the composite numbers because these numbers are made up of factors of more than 2 factors. Okay, since we boxed number 2, that's going to be our first prime number. The second number is going to be 3. Okay, 3 is only comprised of 1 times 3, so only 1 in itself. What we can do then is we can cross out all the multiples of 3. 6 is already crossed out, so we can jump to the next one. 9 we can cross out. 12 is already crossed out. We can cross out 15, and you can keep on going. Okay, counting by 3. 1, 2, 3. 1, 2, 3. I can cross out 21, and please go through the entire list and cross out all of the multiples of 3. You have 24, 27, 30, 33, 36, 39, and you would keep on going. Okay. Okay, now that we've crossed out all the multiples of 3, what you can do is box the next number. 5 is a prime number, so let's list out 3. 5 is also a prime number. And now what we want to do is cross out all the multiples of 5. All the multiples of 5 will fall under the 5th column. It'll also fall under the last column, and those are all done. Okay, after 5 will come 7. Okay, so now we're going to cross out all the multiples. So 7, 7, 14, 21, 28, that's already gone, 35, 42, 49, 56, 64. Make sure they're all crossed out. Okay, so let's see. Actually, 91 is a multiple of 7. Okay, so now that we have that, we can move forward. After 7, we have 11. Okay, multiples of 11. It goes 11 and then 22, 33, 44, 55. All of these have already been crossed out. This should be a 7. That should be a 7. Okay, so that's crossed out. All right. And then you're going to cross out multiples of 13. Multiples of 13 goes 13, 26, 39, and so on. Okay, so you're going to continue this activity. In the end, what you're going to have are your prime numbers. Okay, so starting with our list 2, 3, 5, 7, 11, 13, and I'm going to let you finish up the rest of the activity. And go ahead when you're done, if you're interested, you can go ahead and look up the sieve of Eratosthenes on Wikipedia, and you can actually see an app that runs through this whole activity listing out all the prime numbers, so you can check your answers at the very end. Okay, so we're going to use the idea of a prime factor to do in this chapter what we call prime factorization. Okay, so prime factorization you've all done before, so I'm not going to go into a lot of detail about it, but we're going to use our prime numbers to break down 90. We're going to use in this chapter what we call a factor ladder. Okay, so let's start with the first smallest prime number that you know of. Well, 2, okay, well 2 is a factor of 90. 2 goes into 90 45 times. Okay, now we're going to break down 45. Well, I know that 5 is a factor of 45. Goes in 9 times. Okay, and I can break down 9 into 3 times 3. Okay, I can also break out 3. 3 is a prime number, but you know you can break it out to 3 times 1. Okay, do not stop until you get to 1. Do not stop until you get 1. Okay, so now what we have here is the prime factorization of 90. You have 90 is 2 to the first, there's only one 2, times 5 to the first, times 3 squared. Okay, we're going to use the same idea to break down and get the prime factorization of monomials. So if you haven't already, please write down example number 2. We're going to use the same structure. Okay, well 38 is an even number, so I know that I can divide by 2. Okay, so dividing by 2, I'm going to get 19 rs squared t. Okay, if you completed your sieve of Eratosthenes, what you may have discovered is that 19 is a prime number. So if you divide 19 by 19, you're going to get 1. And you can just write rs squared to t power. Okay, and well, let's break out all of the rest of this. So we have r, you have s squared, s, you'll have s to t, s, you'll have t left, you'll have 1. Okay, so breaking this out, what you have is 38 rs squared t will be equal to, I'm going to move this to the second line, but 2 times 19 times r to the first times s squared times t. Okay, and let me move this third example. See what you can do with this third example. I'm going to move it down a little bit. to give us some more space, negative 66pq squared. Okay, the key here when you're looking at a negative is to factor out a -1 first. Okay, factor out -1 first. There's your hint, and see what you can do with that. Okay. Did you get your answer yet? So we're going to factor out a -1 first. We'll have a positive 66pq squared. Okay, and then we can factor out 3 is a prime number, so I'll be left with 22pq squared. And then I know that 11 is a prime number, and I'll have 2 left over, pq squared, and I can divide by 2, and I'll have pq squared. Okay, so we can also continue this if you'd like. Keep going, but in the end what you'll have is a negative 66pq squared is comprised of -1 times 3 times 11 times 2 times p times q squared. Okay, so that's the prime factorization part. The other part of this section is dealing with something called GCF, or greatest common factor. Okay, so for example 4, what we're going to do is we're going to take a look at these two numbers and we're going to find the greatest common factor. Okay, the neat thing is we can use the same idea of a factor ladder to help us find this greatest common factor. Okay, what we're going to do is we're going to make a double ladder. Okay, this double ladder, you're going to think about factors that will go into both numbers. Okay, so I know they're both even. I'm going to start off with 2. Okay, dividing 2 into 48, I'm going to have 24 and 30. Okay, so I'm going to extend this factor ladder down. Okay, I can divide by 2 again. I'll have 12 and 15. And I know that 3 is a common factor. And dividing again, I'm going to get 4 and 5. And I don't have any more common factors. So my GCF will be all of the numbers on the side multiplied together. 2 times 2 times 3, okay, which is 12. Okay, so we're going to use this idea and extend this to monomials. Okay, if you have two monomials, what we're trying to get is the common factors between the two. So again, we're going to do our double ladder. Okay, what do these have in common? Well, I know they're both even again. I can factor by 2. So 11p squared r. Extending this ladder, I'll have 16p rt. Well, they both have at least one p in common, so now I'm going to factor out one of the p's. Okay, so factoring this out, 11p r, 16, I'm taking out the p, dividing by the p, you only have an rt left. Okay, here let's take a look now. What else do they have in common? Well, 11 and 16, there aren't any common factors there. There's a p here, but there's no longer any other p's on this monomial. They do both have r's, so we can factor out an r from both sides. I'll have 11p left here, 16t here. Okay, so now you see that what we're left with are monomials without any common factors. So that means that our GCF is comprised of these 3 multiplied together. 2 times p times r, which is 2pr. Okay. What we'd like for you to try in your textbook is you check for understanding on page 422, numbers 1, 3, 5, and 7, and also answer this in a complete sentence. Just a quick question. Is the number 1 prime? What do you think? Why or why not? Okay, this is your assignment to bring into class tomorrow, and we will check your answers then.